So what is optimization? Optimization is basically finding the maximum or the minimum values that a function has. We know that already. In this course, we're going to use a little bit of calculus to find out what those maximum or minimum values are. We know how to do with quadratics and stuff like that, but here we'll be able to generalize it so we can do it with any function at all. So, for example, what is the maximum and minimum value of this blue function here? Just by looking at it, we should be able to tell that the maximum value is going to be somewhere up here between 3 and 4, maybe like 3.9 or something like that. The minimum value, well, it looks like it goes all the way down here to negative infinity. We call these values the global maximum because it's the maximum of the whole function, and then the global minimum would be the negative infinity, right? Because it's the minimum of the whole function. Now the question is, we have these other points here, like this point here and this point here, that look like they're sort of in between maximums or minimum values as well. We call those the local maximum. This would be a local maximum because it's the maximum sort of if you look at just this piece of the function. And this is a local minimum because it's the minimum if you look at just this piece of the function, right? So in order to optimize this equation, we need to find what those values are. The global maximum or minimum, or the local maximum or minimum. By the way, these are called the extreme values or the extrema of the function. So using calculus, you should be able to tell if I slide this tangent around. So this is, again, this red point is the tangent. What happens at those points? So if we slide up here to our global maximum, we can see the value of the function is over here. And this is actually the slope of the derivative at that point. What happens as we're at that point? Well, if you look here, our slope of our derivative is not exactly 0, but it's very, very close to 0, right? And we know that about functions. When we're at this maximum point, the slope of the tangent is going to be 0, right? Same thing if we go down here at this local minimum, right? The slope of the tangent is equal to 0. And then coming along here, again, the slope of the tangent is 0. So that's what those 3 points have in common. The slope of the tangent at those points is 0. We actually have, if we continue along and we're paying attention, we can see that there is actually one more point that the slope of the tangent is 0, and that's at this point here at x equals 2. Is this a minimum or maximum? Well, no, it's not, because the function goes up on the left and down on the right. So it's not a maximum or minimum like these other points are, but the slope of the tangent is still equal to 0. So the thing that we should keep in mind for this is that just because the slope of the tangent is 0 doesn't mean it's necessarily going to be a maximum or minimum value. We're going to basically have ways to check to see if it's a maximum or minimum value. So a common question you might get, for example, is determine the maximum and minimum values for x between -1 and 0, for instance. So what is the maximum value when we restrict our domain to -1, between -1 and 0. So that's why I can take these black sliders. By the way, you have access to this Desmos file in the comments below or in the description below. So I'm going to take that to -1, and I'm going to take this side. Oh, I got to move this over actually, or else it's going to disappear. I'm going to take this to +1. Oops. Or 0, sorry, 0. So now we have part of the function, and we're asked what are the maximum and minimum values of this function in that range. And this is a common question we're asked because in applications, usually we come up with an equation, and that equation only applies to a certain part, right? It doesn't apply to the whole equation. So anyways, over this interval, what are the local maximum and minimum values? Well, we can see the minimum value is going to be here, just as we said before. It's the lowest point it reaches, and that's where the slope equals 0. But if we look at the maximum value at this point, we can see that the maximum value between these 2 points is going to occur here, and it looks like it also occurs here, right? At -1 and at 0. And the value of that looks like it's going to be 2. So we would say the maximum over this interval is 2, and the minimum is whatever this value is. Actually, it tells us here that it's 1.4. Okay? So in order to check a maximum or minimum value on an interval, we need to check where the slope equals 0, but also we need to check the boundaries of our interval. Okay, let's do another one. So let's say we make this go from +2 to -2. what's the maximum and minimum values here now? So we can see we have a 0 here, where the slope is 0 here. We have the slope is 0 here, and we actually have the slope is 0 here as well, and all the way over here. So we're asked, what's the maximum and minimum values over this interval? And if we just look at the graph, we can see the maximum value is going to be up here where the slope is 0. We can see the minimum value is going to be down here where the slope is 0, right? And these boundary conditions over here and over here don't actually end up mattering. Actually, this one's very close to that value of 2 as well. But basically, the minimum value is going to be here and the maximum value is going to be here. So the thing to take away from this is that when we need to find the maximum or minimum value of a function, there's two things we need to consider. We need to consider where the slope of the function is 0. That's the first thing. And we also need to consider the boundaries of the interval we're given. Okay?